This question says here that Z denote the complex conjugate of a complex number Z, and this equation is given to us. We have to solve and tell how many distinct roots are there for the given equation. Okay, so first we'll rearrange the equation. Z bar minus Z square is equal to I times Z bar plus Z square is what is given. I'll bring Z bar minus I Z bar is equal to I Z square plus Z square, that is giving me Z bar 1 minus I is equal to Z square 1 plus I. Okay. Now we know the property mod of Z square is equal to Z times Z bar. Okay. Is the same as mod Z, mod of Z bar. Okay. All the three are the same. Right. Now see, in this equation, I'll take modulus of both the sides here. Okay. So mod of this side is the same as mod of the right hand side. Okay. So from there you will get mod of Z bar times mod of 1 minus I is equal to mod of Z square times mod of 1 plus I. Okay. So now see, mod of 1 minus I is root 2 simply, right? And similarly mod of 1 plus I is square root 2. Okay. So this root 2 will get cancelled. I'll be left with this thing now. Modulus of Z bar is equal to modulus of Z square. Okay. And this tells us modulus of Z bar is equal to, now this Z square here is the same as this, right? So this is equal to mod of Z bar times mod of Z, right? So now we have two possibilities here. One possibility is that mod of Z bar be equal to 0. That tells us simply that Z is 0. Okay. So the number is 0 straight away. Okay. That is one solution. That is one possible solution. If mod of Z bar is not 0, that means if Z is not 0, then I can cancel this out. Okay. And then I'll be left with modulus of Z is equal to 1. Okay. Now we have to find the solutions where modulus of Z is equal to 1. Okay. So if modulus of Z is equal to 1, that means mod of Z square is equal to 1 as well. Now modulus of Z square is Z times Z bar, right? So I can say Z times Z bar is equal to 1. So from there you get modulus. So from there you get Z bar is equal to 1 upon Z. That means the conjugate of Z is nothing but the reciprocal of Z. Okay. So now that I know that Z bar is equal to 1 upon Z, I can rewrite this equation as this for Z bar or this one here. Okay. I had this one. So I will write 1 upon Z times 1 minus I is equal to Z square times 1 plus I. This was the original equation given to me, right? This thing here. So I can say from here that Z cube is equal to 1 minus I upon 1 plus I. Okay. Now this thing here, you just multiply by 1 minus I here will become minus 2I upon 2, that is minus I simply. Okay. So I am left with this equation Z cube is equal to minus I. Okay. Now I'll have to find out the number of solutions for this thing here. Z cube is equal to minus I. I already have a solution. Okay. Previously only I had found a solution Z is equal to 0 as a feasible solution. Okay. So I am writing one solution I have, Z is equal to 0. Okay. And I'm trying to find the others possible, if possible. Okay. And I am having this equation here. Let's try to solve this equation. Z cube is equal to minus I. Okay. So Z cube is equal to minus I is what I have to solve and find the number of solutions. Okay. In general, if I have something like this, Z cube is equal to A. If I have to solve this, okay, then what is the solution? Straight away, there are going to be three solutions for this. The solution for this in general would be, I can write Zk is the modulus of A to the power 1 upon n times cos of argument of A plus 2 pi k upon n plus I sine argument of A again plus 2 pi k upon n. Right. This is in general the solution of such an equation. Okay. Sorry, this should have been z to the power n upon a. Okay. So I have n is equal to 3 here and a as minus I here. And what is modulus of a? Modulus of minus I is 1. Okay. And what is the argument? Argument of minus I is? Argument of minus I is, because minus I is what? E to the power minus pi by 2i, right? So the argument is negative pi by 2. Okay. Argument of minus I is minus pi by 2. Okay. So the solution for this one can be written as, and this is for k is equal to 0, 1, 2 until n minus 1. So for here n is equal to 3, z cube is equal to minus I. I'll write for k is equal to 0, 1 and 2. Okay. So the solutions will be, for you put k is equal to 0 here, 1 here. So I will have this thing, z is equal to mod of a mod of minus I is 1 here. So cos of negative pi by 2 plus 2 pi k upon 3 plus I sine negative pi by 2 plus 2 pi k whole upon 3. This thing here. Okay. And now in this one only, you plug k is equal to 0, 1 and 2 to get the 3 roots of this thing. Okay. So when you plug k is equal to 0, 1 and 2, you will get these as the solution. Okay. You will get z is equal to root 3 by 2 minus I by 2 and minus root 3 by 2 minus I by 2 and I. Okay. So these 3 values you will get when you will plug the values of k as 1, 0 and 2 in this one. 0, 1 and 2. When you will plug in the values in this one, you will get the 3 roots here. Okay. So 3 roots I am getting from here and 1 I already had. Okay. So the number of distinct roots I am getting is 4. Okay. So the answer here becomes, the number of distinct roots of the equation becomes 4. That is the final answer. Okay. Thank you.